Hi folks, we're on to part 4 or level 4 of the level up challenge to build a DeFi lending and borrowing contract. Yesterday we implemented the liquidation function and also loan to value or collateralization ratio. And today what we're doing is we're going to implement an oracle. So yesterday we hard coded in how much our token was worth. Today we're going to call a Chainlink oracle and to get the price, which will mean that the price is going to be dynamic and will allow, in the case that the token value changed, that there will be liquidations. So I'm going to do it the same as yesterday. I pretty much just extended the contract from yesterday, and I'm just going to go over it. So I've already implemented it and it's already working, but I'm just going to go through what how I've extended it and what I've done. So the first thing you might notice is this interface up top, and it's interface aggregator v3 interface. And there's just one function in it. One function. It doesn't have the logic of the function. It just has the interface for it. So it's latest answer. It's an external view function that returns an int 256, and this is all we need for calling our Chainlink function. And the reason for that is that we could import Chainlink contracts here. We go import Chainlink contracts and import all the contracts, but we really just we're only going to be using the aggregator v3 interface on the contract, the Chainlink Oracle contract, to call this one function. So we only need to tell Solidity how to call latest answer and what it returns. So that's the way I've put that in there, rather than pulling in all the Chainlink contracts and saying give you aggregator v3 interface with all its logic. If we needed to call something else on the aggregator v3, we need the rest of the things. We could put in another function here, or we could call the contract entirely. So scroll down here. So the first thing you'll notice is that we actually have this in here. It's the Oracle address on the ETH mainnet, and it's ETH-USD is the pair. So we're actually going to value our own tokens in this contract as if they're dollars, so as if they're stable coins. Is the value we're going to give to them. That's the address of the contract there, and we're going to hard code it in here. We could pass it in here, and we could do it like this: data feed equals, and we could do aggregator v3 interface, and we could pass in data feed or whatever. We could Oracle like that and do it in there. But I'm just going to do it this way just for handiness sake and for the demo purposes anyway. Okay, so it's aggregator v3 interface. It's an internal function called that, or an internal variable called data feed, and it is of type aggregator v3, and that is the address. We're actually going to fork mainnet Ethereum into Anvil, and so when we do our testing using our Makefile and our commands in cast, it's still going to work. Okay, so I haven't changed the deposit or withdraw functions. I don't think I changed them at all in this case, so we're just going to leave them as is, and we're going to scroll down here. So we have our borrowTokensWithCollateral function here. Yesterday what we did is we had this calculate max token borrow, and what we did is we essentially just multiplied it. We got the amount of ETH, the amount of ETH, and we multiplied it by 1,000. So we were valuing our token at 1,000 of an ETH. But today what we're doing is we're actually going to call Chainlink and get the value of an ETH, and that's how we're going to value our token. Okay, so again, borrow tokens, they pass in. It's the same function, but what we've done here is to get the max token borrow amount, we call calculate max token borrow amount. We pass in the amount of ETH collateral in way, and what that does is it calls this calculate max token borrow. So it's the same function as yesterday, but in here we're doing a couple of different things. Okay, so the amount in is 5 with 18 zeros after. We trim it down, take off the 18 zeros, and we get 5. So that's going to be 5. And then what we do is we call our ETH price in USD, and what this does is it calls this internal function here and this internal function here, which takes no input. It just returns an int 256. What it does is the int answer, we call latest answer on data feed, and again, as you can see up top, latest answer returns an int, and data feed is aggregator v3 interface. So we're calling latest answer on this data feed here on Ethereum mainnet, and it'll be in our Anvil when we fork it. And what that does is it returns the result. So for example, and it returns the result, just to be clear, latest answer returns 8 decimals. So if ETH is 2,235, say that's the price of it right now, the answer will return 2235 and 8 zeros after, or 2235 E8. Okay, so what we do then is to get the actual price that we'd understand it in the real world. When somebody would say how much is the price of ETH, we'd say, oh, it's 2,235. We just trim off the 8, so divide answer by 1E8, and what it does is strips off the 8 zeros and it returns. So this function returns 2235. Okay, so if we go back up here, we now have this one down here. So we now have amount in ETH, so it's 5 ETH, and the price of ETH. So there, that's apples and apples. That's 5 ETH, and the price of 1 ETH is going to be ETH price in USD. So it's 2235 or whatever it returns. And then we use the max token borrow amount. So we're going to say the amount which 5 ETH multiplies by the price of ETH, which is 2235, and then we return that. So I think that's like something like, I think it's 11175 or something like that. And that's that we're going to say. So just in this instance, we're allowing them to borrow 100% the value of their ETH. So if they've passed in 5 ETH, they can actually borrow every single penny of, or every single up to 100% of that, which would be 11,175 tokens or something like that. Okay, so again, can't borrow the max. Borrow requested too high. So once this is done, all we're doing here is we're really dynamically fetching the price, and the rest of this is going to be the same as yesterday. So it transfers the ETH in, adds it to their balances, and then transfers the token amount out. Okay. So moving on down to the repay function. Again, similar to yesterday, they pass in an amount to repay. The amount to repay has to be more than 0. You have to check that if they have an outstanding loan to repay. Then transfer the tokens into the contract. Update the balances. Okay. And then down here is where we've changed things. Again, yesterday we hard coded this in, and today we're dynamically getting it. So once again, ETH price in USD is the exact same. It's the same function that we're using up here. It's just going to return, for example, 2235 or whatever ETH is at the time. So say that's 2235. Then we're going to multiply. What we do is the amount to repay. So for example, if it's 1,111 tokens, we're going to multiply that by 1E18 to get it looking like this, and then we divide it by the ETH price in USD, and then we pass that over to the payable function to refund that amount of ETH to them. Okay. So what I'm going to do is I'm just going to open up Chisel and show you how this calculation works. So Chisel. So what we're going to do is we're going to do uint ETH price in USD, and that's going to be something like this. Okay. Then uint amount to repay is going to be something like that. So we're going to say 1,111 tokens, and then what we're going to do is uint ETH. What we'll actually do is we do amount to repay, and we call it 18. We'll do 111 like this. That's going to be multiplied by 1E18, and again, if you do amount to repay 18, you should see that there. So it's going to be this number here. It's the exact same as this number here. And then we'll deal with the ETH to refund. Uint ETH to refund, and it's going to be amount to repay 18 divided by ETH price in USD. ETH to refund, and there we go. And that's how much ETH we're refunding there. Do that. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's going to be 0.449, so almost half an ETH, which makes sense because if ETH is valued at 2235 and we're repaying 1111 tokens, that's almost 0.5. It's almost half being repaid, so it makes sense. Exit out of Chisel. Okay, so you can see there that we're paying tokens back into the contract, so 1,100 repaid, and we're getting back basically half an ETH out of that. So that's the repay function working. Then we'll go down here and we're looking now at liquidate. And before I show you liquidate, I'll just show you that we have a new get borrower healthFactor function down here. And I'll talk about that now in a minute. So again, a nuke healthFactor, that'll still work for later on. We'll be able to nuke the healthFactor and do the liquidation. And what I'm going to do here is take a quick look at the liquidate function. So again, it's similar to yesterday. These are actually the exact same, but where it changes then is when we get down here, instead of doing a quick calculation here in the middle of the function, we're actually getting borrow healthFactor, and we're getting it from this internal function down below. So we call get borrow healthFactor and we pass in the borrower. And what happens down here in the borrow healthFactor is this, and I'm going to probably open up Chisel as well for this. So get borrower healthFactor takes in the borrower's address, and in here what we do is we get the amount of tokens that they've borrowed. So they've borrowed, and we call this mapping with that, and it says okay, they borrowed, for example, 10,000 tokens. Okay, now we add precision to it, so we multiply 10,000 by the precision, and the precision we've set up the top. I could have just said 1E18 in the calculation, but we'll do it here. So 1E18 is the precision, and again, what will that do? That will add 18 zeros on to 10,000. So it'll be 10,000 with 18 zeros added onto it. Okay. Then we get the ETH collateral and way. The ETH collateral and way is just what's in there, and again, that's going to be, say it's 5. It's going to be 5 with 18 zeros after. So that's how much that is. Then what we do is we call our oracle again. We get Chainlink price feed, and what that does is it returns it just 2235. So we need to up that by precision as well. So we get ETH price in USD with precision. So you multiply 2235 multiply by 1E18, and what that does is you 2235 with 18 zeros after it. Okay, and then here's where we get our healthFactor. So I'm going to pull this down here, and I'm just going to pop up Chisel again just to show you in action before we test the contract and stuff. So we're going to say uint, and we'll call it borrowed 18, we'll call it. Okay, and that's going to be, we'll call it 10,000 tokens, and we multiply it by the precision, which is 1E18, and we'll just call it to see what it is. So there you go. So it's what would that be? 10 with, it's be 1 with something like 22 zeros after, or 10,000 with 18 zeros after it. Okay, so then we're going to do uint ETH collateral. We'll just call it ETH collateral, and that's equal to, and we say 5E18. Okay, ETH collat, and there we go. And then we're going to do ETH price in USD. I better do uint ETH price in USD, and it's 2235, and we're going to multiply that by 1E18, which again is the precision. Okay, and then uint healthFactor is going to be this calculation here. So ETH collateral, or ETH collat we call it, and we multiply that by ETH. What did we call it? We called it ETH price in USD with precision, which was, oh yeah, ETH price in USD. I forgot to write precision, and they're multiplied together, and then they are divided by that. If you do that, healthFactor, you'll see the healthFactor here. Okay, so copy that, paste it in there, and we go 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. Okay, so as you can see, the healthFactor is 1.175. okay, so healthFactor is 1.175 on that calculation there. And if we go to the top of our contract, or actually we go back to our liquidation, so this is going to be, it's going to be 1.175 and a load of zeros after, which equals, for us it's 1.1175. okay, and the min healthFactor is going to be, again, it's the same as precision, and it's up top, it's 1E18. okay, so just to compare these, I'll just write them into the contract here. So yeah, so for example, min health factor is going to be equal to 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then our user's health factor. I'll do it like that, so that their factor is going to be that. So as you can see, if we say that this is 1 and this is 1.17, so the person is actually, their health factor is absolutely fine there at the moment, because they have their loan is healthy. But then if we go back down here for a second, let's say I was to say, let me see, so we'd say borrowed new 18, and we will say, oh, we'll do uint, we'll go uint borrowed new 18, and we're going to say this person has 999 999. We'll actually do, I'll do that many, okay? That should get us below, well below the health factor anyway. And we're going to say, so that's how many tokens they borrowed, and we're going to do by 1E18. Okay, borrowed new 18, and that'll give us that. And if I go back to this calculation here, and we're going to call it health factor new, and we'll do borrowed new 18. So again, all this means is that they've borrowed more tokens. They still have the 5 ETH, but they borrowed a lot more tokens. So the health factor is going to be different, and the health factor here is going to be this. I'll copy that. We'll call it new health factor. That's going to be equal to that. And if we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, we can see that the new health factor with that many tokens borrowed, 99999, really sinks the health factor down low. So this person is now liquidatable because it's dropped well below the min health factor, which is that. So that's just an illustration of how the calculations work and how to bring them up by orders of precision and so on. Okay, minimize that. So that's how we get past this, to make sure that the health factor is that the user is liquidatable. So in the second instance there, they'd be liquidatable, but in the first one they wouldn't. So again, transfers token for liquidator into the contract, so it transfers in the tokens, updates the balances, and then down here again, we're doing some calculations to what amount of ETH the liquidator is going to get. We did this yesterday with get the amount that the tokens they're repaying are worth, and then we give them a 10% bonus. But the difference here again, not a huge amount of difference. We're just calling this Chainlink. We're getting, instead, I think yesterday we had this down as 1,000, and today it's just going to call Chainlink, and it's going to get the price of ETH in USD, and it's going to return the 22385, and then the calculations are going to be the exact same as they were yesterday. So we'll just go down to, let me see, so that is the end of the contract as far as I know. We've done the liquidate, and we've done the get borrow health factor. So what we can do now is we can do a little bit of testing on the contract just to make sure that it's working. So first thing I'm going to do is I'm just going to show you in the env file. You'll need an Infura or an Alchemy or a Morales endpoint, because we're going to be forking Ethereum mainnet into Anvil. Okay, so this is mine. I'm going to delete this afterwards, so it'll be useless if you try and copy it. But you're going to need it in here. Just, you can call it whatever you want, Infura RPC URL, okay? And what I'm going to do then is I'm just going to open our Makefile, and I will scroll like this, and we'll open this up, and in here the command is just going to be Anvil -- fork URL, and it's Infura RPC URL. Sorry, I do source.env. Clear. Let me try that one more time. And there we go. And so we forked mainnet, and just to be clear, in case you haven't done this before, the keys that we get are going to be the same, so we can still run the same commands and so on. So switch back over. So I'm just gonna make deploy token. There we go. And just if you are doing this, just the token, if you've done this yesterday and you're using the same env file, note that when you fork mainnet, your token address is going to be different. So this is going to be different than yesterday. I've already run this as a test, so I have it in here, but just make sure that you copy it in and you're not using the same token address that you used on Anvil yesterday. Do make deploy lending. Okay, and same for this one. It's going to be a different address, so make sure to put that into your env. And what we're going to do is make approve tokens to lending. Okay, make deposit tokens. Make check tokens deposited. There we go. 1, 2, 3, 4, 5, 6. So deposited 6 in. Make withdraw tokens and clear that. I'm gonna just check them again. There we go. So this should be all very familiar because this is exactly as we did it yesterday, and it's we're just not reading through each one of the make commands, but it's the same as what we did yesterday. So to show you that the contract works, even with the oracles implemented into it. Okay, we do make borrow tokens with ETH. So I'll do this now. So you can see there was a little bit of delay in that, and that's because we forked Anvil, and it's actually calling another contract to get the price of ETH that's in that contract. So that's why there was a little bit of delay in it. Okay, we do make check tokens borrowed. There we go, 4,000 borrowed. Make check ETH balance of contract. There we go. Let me scroll down here again. Clear this. Make approve tokens to lending from Bob. Then we go make repay tokens. There we go. We'll just check the tokens in the contract. There should now be 2889, I think it was yesterday. Check tokens deposited. I think that's it, isn't it? Oh, sorry. Yes, yeah, we've sorry, it's 1, 2, 3. Sorry. There we go, 2889. And now what we're going to do is we're going to try and liquidate Bob. So we do this now again as with yesterday. This is not going to work. Use alone is not liquidatable. Okay. And what I want to do is, so what we'll do is we're going to nuke the healthFactor once again. Nuke healthFactor. Go clear. And again, now we should be able to liquidate Bob. So that's the liquidate. So this is all very familiar because it's pretty much exactly the same as yesterday. There was something else that I wanted to just show you though with this. Okay, so with this one here, when we borrow ETH, I do want to show you on the token contract in borrow, because we didn't do this. Where is it? Oh, sorry, it's up here. Yeah, so just here. So when we borrow tokens, at the moment we are sending and we're saying we want to borrow 4,000 using 5 Ether. But say we wanted to borrow, so ETH is probably priced at somewhere in the 2,000s today. But if we wanted to do this, this should stop us trying to borrow tokens with ETH. Yeah, borrow amount requested too high. So as you can see, what's happening here is that our Chainlink oracle is being called, and it's returning how many 1 ETH is worth. And when we calculate it, we're actually looking to borrow 4,000 tokens, but we're only giving in 1 ETH, and Chainlink is saying actually an ETH is only worth 2,235 or whatever it is of the tokens, and then we're hitting this, you know. So that's just to show you in real time when it's calling the oracle how it's blocking us from borrowing too much.